this one says, in the first quadrant, an even function, f, is decreasing in concave down. So let's see here. Oops. Get my marker. So let's just draw a little sketch. So in the first quadrant, it's decreasing and concave. So decreasing, that's this way, and concave down, so like that. So it's doing something like that in the first quadrant. What can you say about the function's behavior in the second quadrant? Well, I know that even functions are reflected about the y-axis, so it should be doing something like that. So it should be increasing, because we're going up here, and concave down. Okay, and then the next one is going to be similar to one we just did. The point -6, 7 lies on the graph. What point lies on the graph of that thing? So what's going on here? So I have a vertical stretch of 2, and then this goes to the right 3, and then this goes up 4. So let's take our point here, and we'll just plot it, and we will graph it. Okay, so, well, let me make my axes a little bit. So we have -6, 7. So there's my point there. First I'm going to do a vertical stretch of 2. So that's going to be, so I'm going to multiply that y value by 2. So that's going to be -6, 14. Okay. Then I'm going to go to the right 3. So if I go to the right 3, I'll be here at -3, and then I want to go up 4. So that's to 18. Okay, and so first I did a stretch of 2, then I doubled this, right? So I did a stretch of 2, and then I did up 4, and then I went to the right 3, or the right 3 and then up 4. And so that landed, the point that I landed on was -3, 18. Okay. It says the graph of the function y equals g of x is given below. So for this function, we're going to be doing this negative sign here is going to be a flip about the y-axis. This 1/2 means that I'm going to stretch horizontally by a factor of 2. And then this +1 means up 1. Okay, so let's see if we can do that. So the first thing we can do is flip it about the y-axis. So this point moves over here, that point moves over there. And this point moves over here. So we're left with this and that, and then this point moves over here. So 1, 2, 3, 4, 4. So there's my flip about the, so now I've flipped it all about the y-axis. And then I'm going to stretch it by a factor of 2. In other words, I'm going to be multiplying all those x values by 2. So that one moves there. And this one moves 1, 2, 3, 4. So this point is at 4, so I want to go to 8. So it's all the way over here. So that goes there. And then this point here is going to, it's at now, right now at x equals -2, it's going to go to -4. there. And then this point here is at -3. It's going to go to -6. So it'll go here, like that. Okay, so that blue thing is what I want to do. I want to shift it up 1. Okay, so I'll draw my clean graph for what I'm doing over here. So that point is shifted up 1. That point is shifted up 1. This point here at -4, 1 is going to be shifted up 1. And that point here at -6, -2, or -6, 2 is going to be shifted to -6, 3. So then I could draw in my function. Okay. So that's what we have. The next one, find a formula for the function g as a transformation of the function f. So one of the things we might note is that I have a stretch in the horizontal direction by a factor of, or as a squeeze by a factor of 1/2. So so g is going to be equal to, I'll have I'll have a 2x. So that's going to be my my compression in a horizontal direction. And then also I noticed that my vertical used to go from -1 to 1, but now it's going from -4 to 4. So I have a stretch in the vertical direction by a factor of 4. So that means a 4 goes in front here. So g of x, so in other words, g of x is equal to 4f of 2x. And I think that's all that is moved there. So, so there's that.